נראה לי הגיוני.
אני תמיד אם את יודעת את רוחב לאורך הקדימה, אז בא לספור כמה ספייקים יש שם, ואז אבל אני לא חושבת שישאלו אתכם על כמה. אוקיי. At 3 we have to go, so לא. Okay, so I said that I want to give you time for questions, and I think there are many questions, and most of them are in some way overlapping to each one. So I just saw this question in the previous recitation, or this? No, the second one, right? No, one before. This one, right? And I think this is a very, very common question that you'd like to discuss about, right? So do you want us to solve this together, or is there something else more urgent? Okay, so if you're not fully sure how to start to solve this question, so I highly recommend going back to recitation 2 notes. I'll open it in a minute. It's not this. So no, also not this one. I'll just show you from my computer. So these type of questions are highly, no, not 2, but 3, sorry. Okay. So these type of questions are highly related to this type of exercise with the discrete Poisson distribution. So what does that mean? In a Poisson distribution, you have a renewal process every millisecond or every possible size of duration, okay? Every millisecond, every microsecond, okay? You have this renewal process, which means that the probability for a spark will be given by the same peak. If you remember the frog, so the probability of the frog to jump, right, is the same for every leaf. It doesn't matter if it was at this leaf before or not, okay? So the same with the Poisson neuron, so it is for every possible type. But in this type of neuron, I call it the discrete Poisson distribution because then it's not at every possible time, it's only at specific times. So, for example, in this type of question, so you can say that the probability to fire is not for every possible millisecond, but it's if 0 is in relation to neuron A, then for neuron B and C, it could be at 105, 205, 305, 405, and so on, okay? So instead of any possible milliseconds, it's only at specific times, right? And the reason that I tell you to look at the exercise that we did in the recitation is that you need to see that you fully understand this idea. From a given probability of the spike to the probability of a possible ISI, okay? And this is something that I saw that most of you are not fully sure about it, but please note the relation between a probability of a spike to the probability of an ISI, which is a binomial distribution probability, okay? Okay, so let's see here, given these numbers, so how would you start with such a question? And let's add to this question. First, we will calculate the TIH of one of the neurons, okay? So the TIH is the probability of ISIs, right? So let's take, I prefer to take neuron C because it's not the 0.5, so it's a bit more clear. But from C, you can deduce to. Any questions so far? Oh, I forgot. You have 3 questions here now. Okay. So now it's not from the 3 possible questions. Are there any questions now before I start to solve? I said it feels like I'm angry at you. I'm not angry at you. Important to say. I understand why it is hard to connect between the numbers and to this kind of theoretical formula. Okay, so I start. So now we look at these possible times, right? And then I can deduce that the possible ISIs for neuron C are. What are the possible ISIs? 100, 200, 300, 400, and so on. Right? Is that clear? Why? Okay. And now I want to ask myself, what are the probabilities of each ISI? So let's start with the easiest one. What is the probability of 100 ISI? For neuron C fires after 5 milliseconds in relation to neuron A spikes, which are every 100 milliseconds, and probability is 0.2. So what is the probability of 100 millisecond ISI? 0.2, great. What is the probability of 200? Great. So the probability of 200 is that there will be no spike at 100, right? If there was a spike here. So it's a probability of no spike here and then a spike here. Okay? So this is 0.8 multiplied by 0.2. What is the probability of 300 ISI? Exactly. So it's 0.8 multiplied by 0.8 multiplied by 0.2. And then for 400, it's 0.8 multiplied by 3, 0.2. So we can say that for n over 100, right? For any multiplication of 100, it's 0.8 n minus 1 multiplied by 0.2. And how should I plot such a TIH? So I would probably, it gets smaller, right? So the probability is much smaller. So it should look, so you have 100, 200, 300, and so on. So it's like something like this.
And then could you please move the camera a little bit lower if it's possible? Thank you. Like lower on the, we don't see the bottom of the,
Oh,
or
sorry.
you're drawing. Thank you
Is
so
that
much.
okay?
Yes, thank you.
And over here, the distribution, and this is something that we talked about it briefly in class. So there is like a kind of a line, which is an exponential distribution. Okay? So this might help you, the fact that it should look like an exponent. The size of each one. Okay? Great. Now what I want to do is to calculate the autocorrelation. So let's think again. As I said, I would expect, I'm not sure that this is the case, but I would expect that the autocorrelation of such a neuron, the autocorrelation of a Poisson neuron, how does it look? A straight line, right? So I would expect, again, I'm not fully sure if it is like this, that I will have, instead of a straight line, I will have peaks with the probability of 0.2 right here. And this one is at 100, 200, 300. This is what I would expect. Again, I'm not fully sure if it's the case, so we will have to examine it together. Okay? So the basic idea is to understand that this should act like a Poisson neuron, but instead of a straight line, you have the same sizes over here, but it is true only for discrete numbers, not for all the possible. Okay? So this is the hypothesis. Okay. So let's try to check our hypothesis. Yes.
We can, if we can use autocorrelation to,
I didn't think of one.
and to say if the neuron is
Poisson.
Poisson or not,
It is
based on
Yes.
the shape of the.
Yes, as you probably, those of you who read the paper, this is a very common way to conclude whether the neuron is Poisson or not. But I think you already saw in the paper itself that it is debateful. So some believe that there are problems with the autocorrelation and some believe not. And the fifth is to be able to understand the discussion and not to answer the right question because nobody knows what it is. Okay? And this is something which is, I was asked before if you heard about the ChatGPT and why is he so confused from the course. So the reason he's so confused is because all of us are very confused and we are not sure what is the right interpretation of the neurons. Okay, so some neurons are regular and some are just quiet and so on. So we don't really know if it is the right way to simulate. But we can, the fact that you can explain yourself good is enough to answer the question. Okay? Great. So, so let's spin in the autocorrelation. What are the possible values that we have? What are the possible time lapse in the autocorrelation?
This is from your thing, right?
From neuron C. Yeah. What are the possible time lapse that will have a value? Most of them will be 0, but some of them like the exercise, exactly. So it's 100. I'll do it here so we'll have enough space. 200, 300, 400, 500, and so on. Okay. So what is the probability autocorrelation of 100? So since it is the same one as the first ISI, so it is 0.2. Okay? Next, what is the probability of 200? It's a, even if I discuss it in person with you, it's good that you answer. Yes.
No, sorry, I didn't know why.
Because this is the small, a shift of 100 is the probability of ISI of 100, first order ISI. And the probability for ISI of 100 is 0.2. Did you understand that? So in the autocorrelation, this is the smallest possible value. So its probability will be the same one as the one of the TAH. Right? because there could not be a second order ISI over here, only first one. Yes,
Is this zero, the for 200, like 0.2 times 0.2, or like the possibility of it happening twice?
great, so you're now at the 200.
Yeah,
Yeah, so you're explaining it really good. So in 200, you're saying that there are, the first possibility that you're thinking of is
0.2 times 0.2.
exactly. So you're saying in the 200, I need to count also the second order ISI. So there was a spike here, another one here, and another one here. So this is the second order, and this is 0.2 squared.
And then you add,
Or I'll write it like this. Yes,
and then you add the probability of it not happening in the first 100 and happening.
yes. So no spike here and another one here. So this is 0.8 multiplied by 0.2. And how much does this sums up to?
0.2.
Great. Why? Ovid?
I don't know, just calculated.
Okay, so-
8 divided by N.
So you see over here, they're complementary. You see where it is going, right? What is the direction that it is going to, right? Okay, next one. So in the 300s, based on the same logic, Christian,
0.2 times 0.2 plus 0.8 times 0.2 times 0.8.
oh, wait. This is more, a more complicated one, right? Because here you could either have at 0, 100, 200, 300, right? So all of them are spikes. And you can have another one like this. So you had one at 0, and then there was none at 100, none at 200, and another one at 300. So this is the first order ISI. So this is 0.8 squared, 0.2. What are the other possibilities that you were just offering, Christian?
All the combinations of.
Right, yes, you are right. What are the possible combinations?
So, happening first and second.
So I don't know how to close it, but I'll do it here. So there is a possibility that there was one at 0, no spike at 100, and another spike at 200 and at 300, right? And this is 0.8 multiplied by 0.2 squared. And another possibility is that there was no spike here, but there was one here. Sorry, no, what did I? There was one here, but no spike here, and another one here, which is 0.2 multiplied by 0.8 multiplied by 0.2. So let's say that these two possibilities are the same, because it's 0.8 multiplied by 0.2 squared. And this equals to,
0.2.
again, 0.2. Why?
I calculate no.
It's the same idea,
Yeah.
by the way. So you have here the 0.2, 0.2. And this one meets one from here and another one from here, right? So this one sums to 1. Do you understand why?
It's just pretty, it sums to 1.
Yeah, every time you have this 0.2 at the end, and here you have these multiplications which will sum to 1. And here you have the same. This one sums to 1 with this one, and this one sums to 1 with this one. Okay, so all this equals to 0.2. All the possibilities. So again. So in the 400, what would you expect? You have the same, because logically it is the same every time. Right? So it is a Poisson norm, but in discrete times, not all over the graph. So this would be the autocorrelation of such a norm. Okay, and the same with the one with the 0.5 is a bit misleading, because in 0.5, instead of 0.8 and 0.2, which are two different numbers, it's 0.5 and 0.5. So, but the basic idea is the same. Right, so this is the autocorrelation, and from here, what do you say about the cross correlation? Yes,
I just have a question.
yes.
Uh,
It's the right,
for the
I don't take off
autocorrelation,
because when they are asked at the right time, and I forgot to ask you if you have a question, I don't need to take off possible.
It feels like it is a little bit different from what we've done in like other recitation.
Yes,
Because I was not aware that we also have to take into account the spike trends that are not happening. So really how we do it is like, look what, like where it actually happens and the other probabilities are not.
yeah, I understand what you mean, but I think, is it now more clear how to?
How do I know when what? Like how do I know which,
Okay,
because here, this is not deterministic, this is
Yes.
Poisson.
yes, it is Poisson. So if you have a regular, we know that you count.
Yeah.
If you have oscillatory, then you need to. But
Like,
in a
do
way,
the-
if you think about it each time, we try to go into the probabilities, right? So I think the easiest way to solve autocorrelation or cross-correlation problem is by computing the probabilities and then to normalize either to cut or to rate. I think this is the easiest way to solve it. And another thing about how I started to compute it is that I look at the eye size. Okay, I really try to start from the possible eye size and not just from possible spike rate. And when I look at the ISI, I note that there is this binomial distribution, right? This is more easy to see it in the eye size. You understand why? Because it's like success, failure, and so on. So it's easier to notice that this is a binomial distribution. And if it's a binomial distribution, then this is a Poisson. No. Okay?
In the end, the autocorrelation function was like all the way 0 to 2.
Yes, because the idea is that each time you have the values here multiplied by the values here. And if you take, and they are kind of canceling each other because they are complementary by definition. It's clear, huh? After you understand it, yes.
Why does it have the 4 BNC 5?
5.
Yes, from 0, or we consider A is 5 and a half.
Sorry, I should have written here, like this is, you're right, it could be also what the 5. Yeah, the first one might be a 5. But, and this is of course in relation to the cross-correlation, right? I mean, like from A to B or from A to
yeah,
C,
yeah.
so yes, you are right.
When you said that the number is by window or count, so it should always be if it's count, the number of slides, and if it's rate, the number of slides, but also the size of the game.
Now, from probability to count, it's multiplying by the number of spikes, right? From probability to rate, it's just dividing, it's just multiplying by the sampling rate. And not by the average firing rate as I intend to do frequently and to confuse the students. Okay. Okay. So let's try to solve the cross correlation, right?
Isn't like the same distribution, but with probability of 0.01, I mean, you need to multiply the probability of each one
Mhm.
for it to happen, and then the first correlation is gonna.
This is what I think also, you know.
No, if it's infinite, and we consider it infinite.
So I'm thinking to myself, let's do the BNC. So I'm thinking in your direction, to say the truth, but I'm not fully sure. So let's see. Because if it is two Poisson neurons, which are uniform, then for each bin, you just multiply the probabilities, right? And then Ori is right. And I think it is also the case in this one.
It's like a phosphorylation with delta function.
Exactly. This is
So
what
the-
I
the
can.
shape must be.
Exactly. So in a minute, I'll try to make it a bit more complicated. Yes.
I had something similar when I did this, but instead I didn't get that it's the product of the two, like you would get in a Python. But actually, depending on what it's, the probability of a spike in C, assuming the spike happened in B,
Yes.
then, or the reverse, depending on which one you choose, because neurons firing in B and C are not dependent on each other,
Right.
but dependent on A, which always fires at 100,
Exactly.
it actually comes out to just be the same as the autocorrelation of B or C. So if it's the probability that B fires, B definitely fires.
Ah, I understand. So you say when it is from B to C,
Mhm.
since it is a Bayesian probability,
Yes.
so given that B was firing, it doesn't matter if it fired or not, so it
Yeah,
will be the
yeah.
same on the correlation.
So
Ah,
this is being
nice.
equal for B and for C,
Yeah.
probability that C fired is good,
Okay,
probability
so
that C fired.
You're saying that, okay, so we are all quite sure it's going to be, delta function, right? But we're asking ourselves, what is the height of this? Is this, 0.2 multiplied by 0.5? Okay? Or Austin is offering that if it's from B to C, then it will be only the probability of C, right? Which is 0.5.
Why? Why would it?
Oh, wait,
0.2,
C is open.
sorry. Yes, so
But they're not independent, but they fire together.
they're independent. It's not that B is excitatory to C.
Right, but.
C fires
But
anyone,
if A fires, then B and also B and C fire together.
No, with the probability.
Yeah,
let's-
but they're firing together, they're not independent.
No, it's not that they fired together, it's that B fired, and then 100 milliseconds later, did C fire.
yes.
What?
This is the
No.
question in the cross correlation. What
It's not that they fired.
No.
What probability of a spike of B, given that B fired, what is the probability that in C also fired within this time?
But B fired out, so you said.
You are right, if I ask myself what is the autocorrelation of,
So you're talking about the probability of B fires, but the probability of.
Yeah.
of B fire without A firing is not 0.5.
And C,
of B fires,
Given that B fires.
given that B fires, you don't care whether, C fires with B or not.
But
And
it
this
is.
is- Okay, let's really, I'm not sure myself, let's try to compute it together, okay? So let's take the 100 millisecond, okay? So if I have neuron B, then neuron B, it's a probability. Let's look at the process, okay? So if there was a spike here, so I know that the
At the same time, you should still have at the same time.
yes, so in the 100, I don't have at the same time. So you want to start from the 0? I wanted to start from a time lag of 100, but let's start with the time lag of 0, right? So the probability of C to have at the same time, it's not really like at the same time, but at 0 is 0.2, right? Because it is unrelated to B. Do you understand why?
Why
Well-
it's not 0.5?
No,
Or
because- no,
0.2.
because if they fire at the same time, then, I mean, if you're taking that. If they fire at the same time, then A must, I mean, not must, but. It should like excitate both of them, because what's the probability of they both firing at the same time, if they're independent?
I think that over here, this one, the probability of the spike here is 0.5. But you say, I don't look at the times that there was no probability. I look only at the spike trends that there was a spike here.
Okay,
So I don't care what is the probability of B, but there was a spike here. What is the probability that there is also a spike here? Do you understand the difference?
yeah, but if they're independent, then zero, because if there's
No,
no
because-
relation between them,
Here, look, the formula for the base. Sorry,
I mean, you can't consider on the one hand that they're not, that if B fires, then C has a 0.2 probability to fire, but not considering that if
It's
C
the same,
fires,
it's the same thing that you say when, if B fires at time 0, it's the same thing, like saying that A fires 5 milliseconds before, and that's why it's 0.2.
right, but
But why
B
B is
goes
not
to
0.5?
okay,
You confuse the idea that we're looking at a specific time 0, what the probability that he fires. We're not looking at that, we're looking at what if at time
I understand what you're
27.
saying, I'm just saying,
No,
we don't need to not consider it that.
Yes,
We don't-
we're looking at, let's imagine a time 36 milliseconds into this. We see that B fires. At this random time 36, what's the probability that C also fired at time 36? Or it could have been 49. It's not that 0 is literally 0 milliseconds into the recording. 0
I
refers to
understand, but
the time from when we see a spike in B, not based on the probability of a B firing, but that we did see B firing.
But you know,
oh wait, I
B
think,
and C fire together only if A activation.
Yes.
So you cannot take in consideration the fact that the probability of firing in B is also 0.5.
But you don't need to take into account the probability of B, because you know that B fires.
The
I
assumption.
know that B fires and I know that B and C fire together only when A accident.
No,
In
the
this,
assumption,
in this
the
problem.
first assumption for finding the cross correlation is we assume at a given point B fired, not what is the probability that B fired.
Okay, but you're agreeing that if B fires, then C and A didn't accident him, then C won't fire at the same time,
It has nothing to do with A.
but it
B
does.
A fired,
But
and
it does.
I know, what we've said is that B definitely fired.
can I just put on the board this formula, okay? Just to think about. So when you have a cross correlation, it's like asking yourself, what is the probability of C to fire given that B fired, right? Because I'm looking at the spikes at B, at how many times do they meet another spike at C? I'll just wait a minute because last time it was very confusing that there was these small talks in between. So I don't care like letting you trying to discuss with yourself. I will let it in a minute, but let's try to talk together and then discuss together, okay? So what Ori says, it is true since they are independent, the probability of B and C is given by this, right? Because the intersection between them, they are independent, therefore this equals this. But in the cross correlation, you need to divide by the fact that there was a spike. So this one cancels out, and you're left only with the probability of C to fire. This is another way to phrase it, and I think this is what Austin means.
I understand what.
Because you don't want to count into your cross correlation, you are right that if I want to count into my cross correlation, I want to count also the probability that there was no spike here, right? And this is 0.5. This is what you offer, to count also this probability. But this does not mean that a spike here met a spike here. So I think this is about moving from this way that I also initially thought that this is the right way to solve it. But you need to divide it by the probability that there was a spike in B, and therefore this is only the probability of a spike in C.
So,
That's for zero.
so yeah, this would be zero.
Yes,
Relation of B to C in time lap of 0.
yes,
There is a probability of 0.2 that each B will see spike in C.
yes.
but it doesn't switch when you draw it like one, for example, spike train. Should it switch for every spike train?
Yes.
But it doesn't switch,
Really?
yes. For example, when you have A each 100, for B you have at 5 and at 205.
Uh-huh.
For C, you have at 5 and at 405, but each of B, like first of B sees, but second doesn't see, so each half of the B sees spike at C.
But this is very strange because the probability of given that there was a spike here, the probability that this spike will meet another spike here is just the same, right?
Why are we talking about, why are we taking,
The probability of a time lag of 100 milliseconds, it's the same as the one as the zero, right? Because they are independent. Why not?
No, digamos.
There was a spike here at zero.
Yes.
What is the probability that in C there is another one within 100 milliseconds? It's the same as the probability that there is one at zero, right? Because it doesn't matter if there was one here at zero or not.
But spike C fires with probability 0.2. If it was at 0, then the probability of the set in 100, it will be less than 0.2, not 5 or 0.8.
But you don't care about the rest of the spikes here. I just said there is a spike here. What shift do you need to have a spike here? So at 0.2, 20% of the shiftings, you will have a spike here, right? And the C is 0.2, right? So in 20% of the time when you shift C, there will be a spike here that will meet a spike here, this spike that I'm counting in relation to this one.
But it's not necessarily that there will be a spike there.
I don't think we should take
No,
it
it's
as
not
granted
enough.
that B fires. Like,
Yeah.
when B fires, we need to look at C,
But
because
it's the cross correlation of a spike in B.
why spike? I mean, first correlation between B and C.
Yes, so
B
cross
also not
correlation.
fire.
So cross correlation, let's do it in a regular neuron. But first I want to hear more responses and then we will do the cross correlation of the regular one.
Yeah.
Christian,
I
yes.
was just thinking on the like convolution idea that you just mentioned, like the shifting. Like if you think about shifting, I think that makes like full sense. Like think of one spike of B that you know it happens because you're starting a cross correlation, so it has to happen. And then you are shifting B alongside a spike train of C. If you know for a fact that that happened at 100 time lag, it's just the probability of a spike happening in C. It's nothing to do with B because you're shifting B that you know exists already. So like if the idea was you didn't know, then you would be doing the multiplication of probabilities. But because of the cross correlation of B towards C, you have a spike train that even if it's just one spike, you already know it happens, you're shifting, and you're just trying to see from the other spike train, what is the likelihood and what is the probability of a spike happening at that given timeline. So for that, it's just C, like it's a flat line at 0.2 for the cross correlation.
But you agree
But
that
if
B fires more than C.
If you just draw
don't
the spike train
Fire-
for B and
It's
C,
two different things.
Yeah.
B fires
the
more.
whole
Okay,
spike train.
So wait a minute, I want to show you, I want to remind you.
Here.
Okay, I want to remind you, there was a question that we did here, that there is this neuron A and it fires every 100 milliseconds. And neuron B fires from 20 to 30 to 29, 10 spikes, right? And then we calculated the cross correlation from A to B. So what did we do? We looked at a spike at A, right? And we asked ourselves, what is the probability that this spike will meet a spike within 20 milliseconds from B, right? Do you remember that? And it was that the cross correlation from A to B. Do you remember how it looked like? So within 20 milliseconds, there was a probability of 1. Do you remember that? From 20 to 29, it was 9. And it was a probability of 1, right? So let's have again this question. Given that there was a spike here at B, what is the probability that there will be 1 at C, at time lag 0? What is the probability? 0.2, right? And given that there was a spike here, what is the probability of a spike within 100 milliseconds? 0.2. So the probability is not the joint probability of both of them firing together. It's the Bayesian probability. It's the conditional probability. So it's the joint probability divided by the probability of a firing in B. Okay?
But
I disagree, but.
if I
No,
draw,
I think
we need.
it's what a cross correlation really is. I think
Yeah.
everyone's looking at every 100 milliseconds of the entire recording and looking for where does it occur.
Yes.
Not, do we have a spike here? Okay, what is the probability based off of that assumption?
It's
That's the
shifting
condition.
rather than just a
Exactly.
merging. Yeah,
Yes.
it's not every single 100 milliseconds.
Yes.
Two spikes occur together.
And think about it at this one, right? Do you remember when we did the cross correlation from B to A? Do you remember the difference? Right, because only one spike of here will meet another spike within 80 milliseconds. Sorry. This one won't meet the spike.
Question about the probability.
Yes.
So here, like before isolate that, for example, for the first spike of A, I
Yes.
have for 20 seconds after in spike B.
Yes.
I have 20 seconds. Okay, I do have it. For the second spike of B, A, I have after 20 again.
Yes.
So that's the probability of 1.
Yes.
So I'm not shifting B or anything.
So when I say it's the same as shifting it, right?
Yeah.
Because you can shift it.
Yeah.
I'm shifting it by 20 milliseconds and here again. And there will always be
Yeah.
a spike that this one meets,
Okay.
right? It doesn't meet all of them, but there will be one that he meets.
why can't we just,
Is that more clear enough? Sorry.
Yes, I got it, but still, when I have one spike drawing of B and C, I don't have every 0.2, I mean, yes, 0.2
Occurrence, yes.
is also can be, but for one of the drawings, one of the examples of drawings, I don't have each 0.2.
So let me see what you mean. Maybe it's infinite, right?
Yeah, can we draw A, B,
Yes.
and C?
Yes, of course.
You know, I was
Sorry, Austin.
gonna ask about that.
Sorry.
I was gonna ask, could you consider the same possibility, but instead of A deterministically firing?
Yeah.
Talk about what happens if A has a 50% chance.
You still look only at cases that there is a spike.
So does it change? Because according to what some people are arguing,
Yeah.
if A is half, then B should be half the height. Or the cross correlation of A to B.
Right.
No,
Would be-
it's hard.
That's what I- that's
So
what I-
you're saying, let's say, for example, that there is a spike here, right? And then it's only
Right.
in half of the cases.
Yeah.
But not.
So again, so Austin asked really nice. So what is the probability that a spike here will meet a spike here? It's still 1, right?
Why? No, because
Oh. If you
Why?
move
can you
more-
just draw that spike trace?
A spike here will,
By your
the probability, yeah, all the languages are just mixing now. If there is a spike here, you will meet within 20 milliseconds spike here.
yes.
It doesn't matter that there was no spike here and that some of them are, it
Yeah,
doesn't meet.
But the next spike of A will not meet in 20 milliseconds.
But you're not looking at.
Why?
What you're
This is
shifting.
deterministic. right?
No, maybe B as
But it's not the case.
because you know.
Maybe I can
You can just
accept,
draw the spike trains
Okay.
and then.
if we do it on the other way, right? Okay, let's do here from B to A.
Yeah.
So in this one will meet one at 80, but this one not. So what you're saying that in this case, right? So I need to reduce by half the 0.1 into 0.05, right? Do I agree with that?
Yeah.
Okay, so you're saying it is about the same idea now in the probabilities of B and C. Okay? I'm sorry, I really want to hear. I'm sorry for
No, I
for
just
noise.
want you to draw the spectrum of A, B, and C, just like she asked, because this is not the case we're talking about.
Yeah.
And this is just very confusing.
Okay, okay.
Because I
But-
think I really don't understand the cross correlation. If you just draw half of the time and I don't know, or 0.2 of the time, then we will see what you're talking about.
Let's try to draw it. Again, I'm not sure myself about the answer, but I really.
I mean, it is logical, yes, I
Yes.
agree, but when I draw it, it doesn't add up and I'm still confused. And maybe
Okay,
there are
so we
some
have
options.
the A at 0, 100, 200, 300, 400, and so on.
But then you're not going according to like his firing rate.
I didn't understand what do you mean by
It says-
drawing the firing rate?
Eventually, it's exactly what you said. If A, B fire only adds A,
Yeah,
to the B.
So here
The B.
we'll have the B. So B,
Every 200 minutes.
right.
Half of the
Why
time.
every 200?
Because just
It could
half of
be,
the
for
time.
example,
Yeah.
so one possibility is that B is 0.5. So one possibility is that he has in 5, and then in 100 in 5 he doesn't have, and then in 200 and 5 he does have, and so on. And another possibility is that he didn't fire at 5 and he didn't fire at 105, but he fired at 205 and 305, right?
Okay.
And then another possibility is
But
that,
when I do the cross correlation, I need all the possibilities.
yes,
If you want to do it.
yes,
It's not
because
like
it's
doing the
infinite.
auto correlation, I'm not doing the all possibilities.
Also in cross correlation, it's the infinity. So in the infinity, it could act like all of them. It could also be, by the way, that there is one in 5, there is one in 105, and another one in 205, and another one in 305.
Yes, I don't know. Yeah.
Yeah,
Yeah,
right?
but should that answer work for all cross correlation from B to C?
Remember for the auto correlation, we did consider all possible spike trains of B or C. So we do need to also in cross correlation consider all possible spike trains.
That's not final answer.
Excuse me?
The 0.2,
Yes.
is it the final answer cross correlation from B to C for time life of 0?
I think yes. As far as I understand it, yes.
Yeah,
Yeah,
but of course, if we draw C,
yes.
we can draw C.
Okay, great. Let's proceed. So in C, we have, again, we have about the same.
5 and 400.
Yeah, but it can also look the same, right?
It's not,
But
it's not.
so that's why I'm asking, does that answer to fit all the possible probabilities?
Actually, I think so.
Yeah, each time I think this is the idea, right?
Yes,
That
but
it's the probability of C given that be fired.
yes, but it doesn't fit. You can draw C.
Okay, so tell me how to draw it.
5 and 405.
5
Like
and 405.
Yes,
This is one
and the-
possibility.
Yes, and when we do the cross correlation of this 5 train,
Yes.
the second one
So a spike here
meets spike there.
meets a spike there, right?
No, 5, 0 times that.
At 0. But
Yes.
there is another one that you say, what is the other one? So you took only this one with this
Yes.
one, right? No, but this is infinite, so you kind of add them together. Do you understand? After this one,
But it doesn't.
you
mean-
have, this is not only a new possibility, this could also be the continuity of this one, right? And then you have this one. They are just continuing each other. It's infinite. Let's do it like this. Okay, another way to solve this question is saying the following. Let's say that I roll a die, and if I get 4 and above, then I win. Okay? And you roll a die, and if you have 5 and above, then you win. I won. And then what will be the next time? And you roll every 100 milliseconds, okay? You roll the die every 100 milliseconds. So what is the probability that when I roll and I won, what is the probability that you also won? Why?
Because you always win.
So let's look at the die, okay?
Yeah, yeah.
Yes.
Before you, okay.
Sorry.
Okay, for me, it doesn't make sense to draw like a lot of options with a spike frame because it says the probability of a spike occurring here
Yes.
is 0.5. So it can occur or it cannot.
Yeah.
But there are a lot of possibilities. So the probability is saying, okay, at this time, this will happen. That's why I think I think I agree with Ori, although I do not understand completely. But I would say that we have to multiply 0.2 by 0.5 when we do the cross
Okay,
correlation.
so let me explain the idea with the die, because these probabilities, we can also say, okay, we have Yarden will be here. And Arna will be here, okay? Now, Arna wins if it's bigger than 5. So bigger than 5, it's like this, right? And I win if it's bigger than 4. So the probability of me to win every time I roll the dice is 0.5, right? And the probability of Arna is,
Could be squared to, I mean, not to be even 4 bigger, not just bigger.
if I have 4 or 5 or 6, I win. Arna wins only if she has 5 or 6,
Okay.
right? So for Arna, it's 0.2. Okay? So we roll the die, and here I didn't win, here I didn't win, here I didn't win, but only in this one I won, right? And here Arna also rolled die, so she has 1, 2, 3, 4, 5, 6. So here she won. But I don't care about these cases, right? Because I didn't win, so I don't count them in the cross correlation. I don't count the times that I didn't win. I look only if I won, what happens here. So let's see what happens here. So in each time like this, right? This is all the possible combinations between the winning of me and Arna. Also here, and also here. But again, I don't care about the times that I didn't win.
But it's not the case in the,
Wait a minute.
okay.
Okay, I think it is the case, but I will hear you in a second. So here, the probability of Arna to win, it's again the same, right? I won, and the probability of Arna is again 0.3. And here again, 0.3. And here again, 0.3. So I won when there was 4 in half of the cases, right? I won. What is the probability that Arna also won when she rolled the die with me? What is the probability? 0.3. Again, I rolled, I won. I'm counting only the times that I won. What is the probability that Arna won? Also, when she rolled with me, it's 0.5. So for this reason, it is not what is the probability that also I won and also Arna. It is only given that I won, what is the probability of Arna to win? Okay, so this is how I see the problem, but please tell me what is wrong about this point of view.
Just lost my thought.
Sorry. I just really had to finish. Okay, so think about it. Yes, I'll say.
Yeah, but we are assuming here that these are independent, and in the case of the neurons, we don't know. That's what we want to find out with the
Yes.
cross correlation. So for that reason, I believe that we should not put 0 in B when we do the cross correlation, because we are assuming that neuron A is the only thing that both B and C are dependent on.
Yes,
But we are not sure if they are dependent
on each other. Yes,
And this is what we're assuming here, that they are independent, but we are not sure. So that's why we
Yes.
have to multiply 0.2 by 0.5 in the cross correlation.
ah,
But it doesn't
But-
connect exactly downstream here on A.
When-
because
But-
cross correlation is not what is the probability that both neuron B and C fire together. It's what is the probability that neuron B will see a spike of neuron C within this and this time, right? It's different. So this is why I think the joint probability that this argument that you are calculating is a bit misleading.
Well, but when are we checking if the two are dependent or in this question?
In this question, we don't, but for example, it might be a harder question that they say that neuron B inhibits neuron C. So if it fired, right, the neuron C will not fire in the next one, for example. And this was one of the questions that you also asked me.
But I think that when we're talking about cross correlation, that's what we're trying to find, is if one of the neurons has an effect on the other.
Yes,
So if we assume independence, why would we even calculate cross correlation?
so in this one, they're independent, but it doesn't say that they,
No, I mean, that's what we are trying to find out.
right, but it's a mathematical tool. It doesn't mean that it does find it. For example, here they are independent, but it looks like they are, right? Because there is some probability. So the idea about all this calculation is just showing you that not everything says that they are dependent. You need, for this, you need to add some statistical measurements like shuffle and so on that you were asking me about, but you don't need to use it. But in real life research, what you do when you calculate the cross correlation, you also shuffle the data. What does that mean? You make a random connections between B and C. For example, you shuffle the spike plane, or you shuffle, I don't know, you can shuffle a lot of things. You need to know what to shuffle, and this is what your PI teaches you in this field.
Yes.
And then when you shuffle, you have a baseline, and you subtract the cross correlation from the baseline. And only then it means if it's significant or not. So what you're saying is it's about the question of significant connection, right?
So then what's cross correlation?
Cross correlation is what is the probability of a spike in B to meet a spike in C within this and this time. Yes, Crystal.
I know the time is running low, but I do want to talk about the last question on the quiz review that you sent, like the one that you sent on email. It has a very similar like scenario as this one. That's why I just wanted to bring it up really quick.
Okay.
Because it says, so basically it has A firing into B and then A firing into C. And then the firing rate changes.
Right, from B to C.
So in that case, it also asks us to do a cross correlation of B and C and D.
And there is no solution for that, right?
No solution for that, but like
Because-
thinking of all of what we just discussed, would then the solution be the cross correlation of B to C and and
So-
C to B equal to the cross correlation of A to B and A to C? Like, does that make sense? Like,
No, I think in this one not, because then you have it's more like this one, okay? So you have the probability of each beam to have a spike multiplied by another spike over here.
but that one isn't in, like, it's a direct, like, isn't it directly connected? Aren't those two neurons directly connected?
So you know what, over here, I did, oh, where is the cross correlation? So there was also a question here.
No, about,
Yeah, it's the right.
like the, but not the one distribution. That's the one.
No, wait a minute, I did send you. Maybe it's this one? No. Sorry, I just really, it was here. Here. And recitation 5 notes. So here it was this one. Here, the cross correlation of this one.
Okay.
So this is how you calculate it, okay? So I would look at this one, although A is a regular neuron. So the basic idea is that you just shift C to have a correlation with the spikes of A, and then you look at how many correlations like this you have. I hope that it answered you, but this
Yeah,
is
no,
how.
that's the answer that I had in the beginning. I just thought about a new like way of doing it after like having
Yeah.
this conversation.
Yes, I am.
Could we also just do the hazard, actually, maybe? I
For
don't know.
this one,
No, for the one before, like the, regular B or C, and I think the time is running out, but I.
yeah, I'm really wondering what to do.
I would
And
like to do an example for this image, like a concrete example.
yeah, I just really have to take my children from
Yeah, I
the
know.
kindergarten, I'm sorry. So, like the one that we discussed of?
Yeah,
Okay.
this was like,
So,
this example.
Let's do like this. Send me in person on WhatsApp, the 2 questions that we discussed. I'll try to write a solution and send you, okay?
Yeah.
Yeah. Yes, of course. But I hope that it helped you in a way, because we also spoke in the PSCH about using the expectation. And this is what I will do. Yes, I will. No, you don't take the multiplication, because if you know what is the probability of to have a spike here and to have a spike here. It's that there is a spike here. What is the probability that it emits another spike here?
But it might be.
But you say that if these are 2 Poisson neurons, right? Okay, let's think about the Poisson. If it were a Poisson neuron, then what would you calculate? Here, this is the probability to have the beam here. I understand what you mean. So here is what's on our multiplication, because you multiply the beam.
You can't know the fact that but we fire only in half the cases. If you're taking the A fire in 0.2 cases, you must consider that we also fire in
But then I have because you mentioned you're one, so don't have it. You're not basically actually here.
Yeah, but then we have to break it down. Then you ask yourself, in how many cases, what is five? You make five second. If there was five here, what is the probability of you need five here? So it doesn't matter if there wasn't one or not.
But it does, because you're considering the 8 fires, right? So if 8 fires, then there's a probability of 22, there's 3 and 5. So when taking into account, there's a probability that if 8 fires, then there might be another 5 here that there's another 5 here. There isn't one, but there's one here, and you will meet it.
Yeah.
So you need to consider that can only happen in cases when you have 5 here. Because this multiplication, we by not ignore this multiplication.
Okay, because now I want to talk about the poisson, that we multiply the matrix, right, each time, like in the other
Yeah.
Okay, let's not have it. Because again, I'm thinking to myself that the cross correlation is that given that there was a 5 here, what is the probability that makes 5 within this within 100?
But then it's not 22.
Why?
Here.
Because,
Given that there was.
okay, they're not related to each other. I mean, how can you, I mean, you don't know that this is 22.
Yeah, you have this formula that, what is the event? Given makes sense. Like, what is the and the joint probability of both of them divided by the probability of this, right?
You're taking into consideration the 5 for sure. So this one's 1.
Right.
And why would that change the overall?
The probability of B.
Okay.
אני חושבת שגם נכון, אבל השאלה היא מה שיש לי באותו קורלציה זה הדבר הזה, או הדבר הזה, צריכה לבדוק. עד כמה זה נכון?
The value in the constellation.
אתה מבין, אתה אומר לי כל הזמן, למה שעשיתי, כי אצלנו באותו קורלציה זה מה שעשיתי. קרוס קורלציה, אם אנחנו לא לקחת את הדבר הזה. כי הטיעון שלי מאוד מאוד משכנע. שאם היה רגולרי, היה ספייק ב-A, אפילו שהיה חצי מהספייק, בוודאות תהיה גם לבדוק את זה, היו כאלה שלא, כאילו שלא פרשים אותם
יש בין שני ריבונים. פה זה לא כמו להשאיר. פה יש לך איזשהו...
מאוד אקספטורים שהוא עושה לשניהם.
זה לא אותו קשר, זה לא אותו דבר. זה לא אותו דבר.
אני לא רוצה להגיד סתם כן.
נכון, אמרנו שזה כאילו בגלל שזה הסתברות מותנית, אז